In this video, we take the limit as n approaches infinity of n minus the cube root of n cubed minus 5 times n times the square root of n. Okay, first let's work with n times the square root of n. That's just going to be n to the 3/2 power. And now we have to distribute this to both n and the cube root. So n times n to the 3/2 is n to the 5/2. And then I'm just going to put the n to the 3/2 in front of the cube root. And then what I'm going to do is bring this inside the cube root. So if I want to bring it inside the cube root, that means I have to cube it. So you apply the opposite. So the opposite of cube root is cubed, so we do n to the 3/2 cubed, which is just n to the 9/2. And then I'm going to distribute the n to the 9/2 to both of these terms. So I'm going to get n to the 15/2 minus 5n to the 9/2. Now we want to use the fact that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. In this example, we're going to have a equal n to the 5/2 power, and then b will be the cube root. So that leaves us finding a squared plus ab plus b squared. So this is a squared, a, b, and then b squared. So we're just plugging in a's and b's for this. Okay, now let's bring it all together. Think of this as like our limit that we actually want to solve. This is the original limit with the n times the square root of n multiplying everything, which is a minus b in other words. And then this is a squared plus ab plus b squared. And that's going to be all over a squared plus ab plus b squared. So when I multiply this, I should get a cubed minus b cubed over a squared plus ab plus b squared. Okay, so recall a was n to the 5/2 power, b was the cube root of n to the 15/2 minus 5n to the 9/2. So I'm cubing n to the 5/2, and then I'm cubing the cube root. So when I cube the cube root, it's going to cancel. And I want to make sure that I put a parenthesis around the inside, since I have a minus that has to distribute to both. And then n to the 5/2 cubed is just n to the 15/2 power. So now the n and 15/2 are going to cancel, and I'm going to be left with 5n to the 9/2 power on the top. And so at this point I look at, okay, what is the highest degree exponent? And if you look at it, it's going to be n to the 5th. So I'm going to divide, or in other words, multiply everything by 1 over n squared. I'm sorry, n to the 5th power. So the highest degree is n to the 5th, so let's divide by that. So we have 5n to the negative 1/2. This n to the 5th becomes 1. This becomes n to the negative 5/2. And then we're just going to stick an n to the negative 5 in front of this parentheses. So now this n to the negative 5 needs to come inside the square and the cube root. So that's going to take 2 steps. And this n to the negative 5/2 has to come inside the cube root rather. So in order to go inside the cube root, you have to cube it. So n to the negative 5/2 cubed is n to the negative 15/2. And first, the n to the negative 5 has to go inside the square. So you do the opposite of the square, which is the square root, to get n to the negative 5/2. And in order to go inside the cube root, you have to cube it. And then for this one, you just have to distribute. So you get the cube root of 1 minus 5n to the negative 3 power. And then here, when we cube n to the negative 5/2, we get n to the negative 15/2 power. So again, this is going to have to distribute. So we get it again, 1 minus 5n to the negative 3. At this point, we're going to bring this n to the negative 1/2 power in the bottom as just n to the 1/2 power. So what we see is that 5n to the negative 3 is going to go to 0 as n goes to infinity. So it's like 5 over n to the 1/2 power is going to infinity, and it's like 1 plus 1 plus 1. So it's basically 5 over infinity, and so this goes to 0. So our final answer is 0.